Okay, beta. So let me now set up the presentation for plotting of sites. Known as graphical combination of sites and is also known by the name of staggered observations and simultaneous observations. All these names meaning the same thing. Let us now try to understand what this actually is. In celestial navigation, we have worked upon celestial sites, celestial observations, using different bodies, sun, stars, planets, and moon. We have used different methods depending upon the situation, like meridian passage, latitude by meridian altitude, long by Crone, intercept, X meridian, and Polaris. Now, all these methods have given us position lines. If we take one celestial observation or if we take one celestial site, we can obtain one position line for that time. Now, the ultimate aim of the navigator is to fix the vessel's position. So, the ultimate result which we want from this exercise of site taking or observations is that we should be able to fix up the position of the ship. If we have a position line, it just signifies that the vessel's position lies somewhere on that position line. It does not tell us where is the vessel right now. It could be the position line could be running in dangerous waters. It could be running in safe waters also. So just knowing a single position line does not help the navigator much. What we are ultimately interested in is getting the position of the vessel or getting a fix. Now for getting a fix, we need to have minimum 2 position lines. If we have 2 such position lines, then we know that wherever these position lines intersect will be our position. So this is our ultimate objective for site taking, that we should be able to obtain at least 2 PLs, and combining those 2 PLs we should be able to get the position of the ship. So beta, I hope everything is clear up to here.
Yes, sir.
Yes, sir.
Very good. Now for obtaining 2 position lines, we need to work at least 2 astronomical sites. One observation gives us 1 PL, the second observation gives us the second position line, and once we have these 2 PLs, we can plot them on the chart or on our plot, and wherever these 2 lines intersect will be the position of the ship. Now it is possible that 2 celestial bodies may be available to us at a particular time. So in that case, the site can be taken for both these bodies at the same time. And if 2 sites are taken at the same time, it is known as a simultaneous observation. Now in some other situations, it is possible that there may be only one celestial body available to us at a particular time. Let us say, for example, you want to take a site during daytime. The only body which may be available at that time could be the sun. Now with no other celestial body available, it is not possible to take a simultaneous site. You cannot take 2 sites at a single time. So what can be done in those scenarios is, you can take one single site of the body and then wait for some time, let the sun move a little bit in the sky to another location, and after some time you use the same body to take the site again. Now after some time, when you take the site again, you get a different position line. So now in this case we have 2 position lines for different times. These can also be combined and can be used to get the fix of the ship. This type of observation is known as a staggered observation. If sites are taken at different times, then they have to be transferred to a single time. While transferring, we have to allow for the vessel's speed and course, and if there is any external factor like wind or current, they also have to be taken into account and the position line transferred. Now, this kind of observation is known as a staggered observation. Usually on board a ship, when we take sites and we plot them, we are able to plot them on the chart. We have the chart of that particular area available to us. We can plot the position lines on the chart, and once they are there, whichever position they intersect, its latitude and longitude can be read off from the chart, and we have the vessel's position known to us. But in our paper, the plotting questions, staggered or simultaneous plot or graphical combination of sites question, may come in the practical navigation part. It may not come under the chart work part. So usually it appears as question number 5 or 6 of our paper, and it does not relate to the chart which is given to us. Means you will not be able to plot these sites, plot these position lines on the chart. So how do we get our position now? We have to construct a small part of the Mercator chart on our answer sheet. It can be done on a plain paper on our answer sheet, or sometimes they provide us with a graph paper. It can be done on the graph paper. The graph paper gives us a little bit of advantage. It has parallel lines and perpendicular lines, which we can use to draw our latitudes and longitudes. So otherwise the procedure can be done on plain paper as well as on graph paper. Now this procedure of constructing a small part of the Mercator chart on our answer sheet or on the graph and plotting 2 or more position lines to get the vessel's position is what we know as plotting of sites. So this is our ultimate aim now for plotting of sites. Now when we plot the sites, we are provided with information which we obtain from a observation. We have seen different observations: Marpas, Long Bicron, Intercept, X Meridian and Polaris. Now whatever information we obtain as answer from these sites by working out these sites, that is basically a reference position from where the PL passes and the direction of the PL. These are the two information which we get from working out a site. This is provided to us in the plotting questions. So we have the site worked out and its information given to us, and we need to plot it on our answer sheet or the graph paper and find out the fix of the ship. So beta, I hope it is clear up to here. Any doubts, please share with me.
Sir, can you go back one slide? The first one, sir. I just take the picture. That's all, sir.
Okay, beta. Just give me a minute. I'll go back. This one?
Yes, sir. Okay, sir. Thank you.
Okay, beta. So moving ahead now. Now, before we go into the actual procedure of plotting, let us refresh some features of Mercator charts so that we are clear about how to make a small portion of this chart on our answer sheet. Now, on a Mercator chart, all the meridians are parallel, and 1 nautical mile is equal to 1 minute of latitude. The distances are measured in nautical miles, or in other words, you can see that the scale of distance is same as the scale of latitude. The north-south distance measured on a Mercator chart in nautical miles is equal to the minutes of DLAT between the two places. The east-west distance between two places measured along the latitude scale gives you the departure between them in nautical miles. If you measure the east-west distance between two places along the longitude scale, it will give you the D-long. But if you measure the east-west distance between two places along the latitude scale, it will give you the departure between them in nautical miles. So these were some features of the Mercator chart, which will help us in constructing a small part of it on our answer sheet. So beta, any doubts up to here?
Sir, can you explain the last points, east-west distance between two places measured along
Okay,
latitude
beta.
scale?
Let's visualize that you have a chart in front of you and you have two positions on the same latitude.
Yes, sir.
Right? Now you pick
Yes,
up
sir.
a compass or a divider and you measure what is the distance between them. You can measure it in two ways. You can measure it in latitude scale or longitude scale, right?
Yes, sir.
If you measure it on longitude scale, it gives you the D long between those two positions, right?
Okay, so in that case, the 1 nautical mile equal to same 1 minute of longitude.
No,
In that
first you
case, sir.
understand this better. You pick up that compass,
Okay.
take it to the longitude scale, it will give you the D long between them. You agree?
Yes, sir.
Now, if you pick up your compass and take it to the latitude scale and you measure what is the value it is showing, that will give you the departure between those two places. So up to here
Yes, sir.
clear?
Departure. Yes. Okay, sir.
Now, when you measure the departure along the latitude scale, the departure is in nautical miles because 1 minute of TLAT is equal to 1 nautical mile.
Correct, sir.
Okay, बेटा. So चलें बेटा, आगे चलें.
हाँ सर.
Yes, sir. Thank you, sir.
Very good. Now, as we have seen that on a Mercator chart, the east-west distance is the departure between two places. Now, when we make a small part of the Mercator chart on our answer sheet, you see on an actual Mercator chart, there are two different scales. We have the latitude scale and we have the longitude scale. Both of them are different from each other. That means 1 minute of latitude will be different from 1 minute of longitude. Now, if we are making a small part of the Mercator chart on our answer sheet, it will be very complicated and time taking to make a chart having two different scales. So in our chart, in our plot, we do not use two scales, we only use one scale, and that scale is the latitude scale. Now, if we have only one scale on our plot, then you have to measure all the distances, whether they are in the north-south orientation or the east-west orientation on the latitude scale itself. The north-south distance measured along the latitude scale is the DLAT, but the east-west distance measured along the latitude scale is the departure. So we need to make sure that whenever we have to show a east-west distance on our plot, we have to show that distance as departure, not as D long, because in our plotting, we do not use the longitude scale at all. So for putting any information or position on our plot, we will use the east-west distance as departure. Now, how to get the departure? Departure is obtained from the parallel sailing formula, which is departure is equal to d long into cos of m lat. M lat is the mean latitude. So whenever you want to put or feed or show the east-west distance on our plot, we will calculate the departure and then use it to show that particular distance on our plot. Likewise, when we are reading off any distance, east-west distance from our plot, we will always get the departure and we will have to convert it to d long using the same formula. Any east-west distance entered in the plot should be the departure, and any east-west distance picked up from the plot should be the departure. It should be converted to d long for our use. So clear beta, चलें आगे. Very good. Let's go. Now going a little further in plotting, the plotting can be done on plain paper or if possible graph paper. Whatever plot you do, it should be based on a certain scale. To give you an example, the scale could be 1 centimeter is equal to 1 nautical mile, or if required, it could be 1 centimeter is equal to 2 nautical miles. Whatever scale you select, it should be clearly mentioned in the plot. Without the scale, the plot is meaningless, and it is a very important items to be shown in the plot. Most convenient scales to use are 1 centimeter is equal to 1 mile, or if the diagram is not fitting on our answer sheet, the plot is big, then it can be made smaller by taking a scale 1 centimeter is equal to 2 nautical miles. Most of the questions you will be able to solve using these two scales. Now, even if you have to use a bigger scale for some question, avoid putting any fractions in the scale. Avoid taking 1 centimeter is equal to 1.5 mile or so. So fractions in scale will lead to errors. It will become difficult and time taking to convert the values, plot values to actual values. So fractions should be avoided. Now in staggered plotting questions, we need to transfer a position line. Now the position line can be transferred using two different methods. Either the PL can be transferred by applying the course and the distance steamed by the vessel to any point on the position line. The first method is you can straight away apply the course and distance on the position line, any point on the PL. You reach to a new point and you draw a line parallel to the initial PL and the PL is transferred. Now the second method is using calculation. So in calculation, we pick up any point on the initial PL, apply plane and parallel sailing to it and find out the position arrived after a certain course and distance has been applied to it. So this is the calculation method. We can calculate the new point or the new reference position from where the transferred PL will be passing. Now, which of these two methods should be used in a particular question? If the distances involved are less than 10 miles, you can directly apply the course and distance geometrically using the plotting tools. But if the distance exceeds 10 miles, then you should prefer using the calculation method.
Sir,
go ahead, beta.
Can you please repeat the second method again, please?
Okay, don't worry, beta. I will be doing both these methods. The first method is as you do in chart work by applying the course and distance to the PL. And the second method is by using calculation by doing plane and parallel sailing. I will be showing you both the methods in the practical questions which we will do. Okay, beta? Okay. Okay, beta. All right. A reason for this being that if the distance is more than 10 miles, to show it on your answer sheet, you will have to select a large ratioed scale, maybe 1:5 or 1:10 or so. Now, as the scale becomes bigger and bigger, the errors in the plot get enhanced. If you have a scale of 1:10, then 1 centimeter is getting converted into 10 nautical mile. That means 1 millimeter on your plot is representing 1 nautical mile. Now 1 millimeter error on the plot is very much possible. The thickness of the pencil or the accuracy of your compass or divider can easily take you 1 or 2 millimeters up and down. And in that case, it will give you excessive error in your answers. So in case you have a distance more than 10 nautical miles, then the PL should be transferred by calculation, and you should avoid doing it by plotting. So we will see that in the examples going ahead. So any doubts in these points, beta?
No, sir.
वेरी गुड बेटा. अब बेटा दो चीजें आपको यहाँ ध्यान में रखनी है. वन इज दैट दिस क्वेश्चन ऑफ प्लॉटिंग इज वेरी सिमिलर टू व्हाट यू डू इन चार्ट वर्क. The only difference here is in chart work you have a chart, and in plotting we have to do it on our answer sheet. That is the only difference. Otherwise, all the methods which we do in chart work, they are applicable to plotting also. So it is very similar to chart work. And number two, I told you PL can be transferred by two methods. One is by plotting it on the plot, exactly as we do on chart work. Second is by calculation. Now, when you transfer a PL using calculation, you need to be familiar or you need to be thorough with plane and parallel sailing. Equal to, what is the formula?
Distance cost.
Post force.
Very good.
Departure
Departure is equal to?
Distance to sine course.
Very good. And tangent course is equal to?
Departure by delay.
Very good, beta. So when we do plotting or when we transfer a PL using calculation, we will be using these plane and parallel sailing formula for calculation. Okay, great. Let's go back to the presentation. Let me now briefly tell you about the steps which we follow in these type of questions. It is very important that when you start a plotting question, you understand the question well. Analyze the information, what is given to you in the question, understand it well, and once you understand the complete information, you can go ahead and make a rough diagram or rough plot. The rough diagram puts all the information in a pictorial form, in a picture in front of you, and it gives you a lead into how the question is to be solved. Now, once you have the rough diagram and you get a lead how the question is to be solved, you can go ahead and do the final plot. The final plot can be done now, and whatever calculations are required, they can be shown alongside the plotting. Always remember in these type of question that the question has to be solved first in your mind, and once you have clarity, then the question can be solved on the answer sheet. So any doubts up to here, beta?
No doubt, sir.
Very good, beta. Great. So we have done the basics. I'm closing the presentation now. So we have covered the basics. This is the basic info. Jump into the practical questions. So I'll be showing you these practical questions through a video. So let's set up the video and jump into the questions. Give me a minute, beta. I'll set it up.
So later you'll be sharing the video, right?
Say again.
So later you'll be sharing the video with us
No,
on
beta,
YouTube or
that
something.
video is available on Marine Gurukul. So
Okay.
if you wish, you can watch it again there. I'm not sure whether it is under paid ones. It may be under paid ones, beta. But you can see it
Okay.
there. Any doubts, you can ask me directly.
But sir, there are some videos which is paid one, sir.
All right, beta. मैं दिखाऊंगा अभी आपको. So don't worry about that. Any doubts, you ask me.
वो नहीं sir, during grade circle, no? The advanced one is paid one. I was watching that, but the advanced one is the paid one.
कुछ फ्री
No
कहाँ
problem.
मिलेगा भाई?
बेटा आपको अभी क्यों चाहिए एडवांस्ड वन जब मैं सारी चीज समझा रहा हूँ? Why do you need the videos?
सर थोड़ा रिकॉल करने में एक्चुअली हेल्प हो जाता है.
बेटा रिकॉल यहाँ करना है माइंड में. MMD में वीडियोस थोड़ी काम आएंगे. So WhatsApp group will remain active even after the course is over. So whenever you have any doubts, you ask me na.
Okay, thank you.
Similar to what we do in chart work, with the only difference that we don't have a chart and we are doing it on plain paper, our answer sheet or the graph paper. So let's go into first example.
Example, in DR 50 degrees 10 minutes south, 140 degrees 40 minutes east, star X observation gave an observed long 140 degrees 36 minutes east. Azimuth 075 degrees true. At the same time, star Y meridian altitude gave an observed latitude 50 degrees 14 minutes south. Find the vessel's position.
Okay, beta. So first of all, you just read this question. Any doubts coming in the question, please let me know.
No doubt, sir. No doubt.
Very good, beta. Great. Let's go ahead.
Now, before we proceed any further, it's important to identify the methods deployed for solving the site of star X and star Y. I'm sure we can all figure out that star X has been solved using long-by-cron, and in such case, the PL shall be drawn through DR lat and observed long. Direction of the PL perpendicular to azimuth. As far as star Y is concerned, it's a meridian altitude observation. So the PL shall be drawn through observed lat and DR long, perpendicular to azimuth, but in this case of meridian altitude, the PL shall be specifically east-west, and hence it will coincide with the parallel of latitude of the observed lat. Now, having identified the processes deployed for solving the sites, we proceed ahead with the plotting. We have the DR lat coming up on the screen. We have the observed lat. Now, the D lat from DR lat to observed lat is 4 minutes south. This information shall be used to plot these two parallels with respect to one another. Direction of PL of X, as already said, it will be perpendicular to 075 degrees to the azimuth, so shall be 165 degrees to 345 degrees. Direction of PL of Y shall be east-west, that is 090 degrees to 270 degrees true, being a meridian altitude observation and solved by latitude by meridian altitude. Now we come on this side.
Okay, before we go into the plot, beta, all these values which we have written down, any doubt in any one of them?
No, sir.
Very good, beta. Great.
Excuse me, sir.
बोलो बेटा.
Excuse me, sir.
हाँ बेटा बोलो, थोड़ा सा जोर से बोलो.
ओके सर, ओके।
सर ये डी लैट DR टू ऑब्जर्व लैट का मतलब क्या हुआ? मतलब
बेटा हमने इन दोनों लैटिट्यूड्स में डी लैट निकाला है. ओके, दैट इज द ओनली थिंग. दिस इज व्हाट वी रिक्वायर.
ओके सर.
ओके सर,
If you go from DR lat to observe lat, you will have to go 4 minutes south. Okay.
Okay.
Very good, beta. Great.
सर तो पहले हमने इसके सॉल्व किया है ना ऑब्जर्व लॉन्ग बैकग्राउंड मेथड से और मेरिडियन मेथड?
नहीं बेटा, इसको हमने सॉल्व नहीं किया है. ये क्वेश्चन ऐसे ही आएगा. इसमें आपको ये वैल्यूज दी गई होंगी जो रेड कलर के बॉक्स के अंदर हैं. द साइट विल बी सॉल्व्ड. Very good.
We have this DR latitude, the parallel coming out here. Then we decide on the scale that we would like to use. So we'll use, as far as graph in the background is concerned, one big box as 1 centimeter. If without graph, we can take 1 centimeter as 1 minute. So the observed lat has to be 4 minutes south of the DR. So we go 4 minutes south, D lat 4 minutes south, and we draw the observed parallel of latitude out here.
So okay beta, two latitudes are plotted. Any doubt up to here?
No sir.
Very good.
Now in this case, the latitude that the meridian that we shall need would be the observed long. So we draw the observed long. It's drawn out here. Now we all know that for star X, the PL shall be drawn through DR lat and observed long, that is this point. And direction as already calculated as 165 to 345. So we have this PL for star X coming up here, passing through this point.
So the first PL position line for long by Crone has been plotted. So have a look. Any doubt in how this PL is plotted? Let me know.
Sir, we don't need to show the azimuth, no, in this diagram.
If you want, you can show that also. But if you have shown the calculation here, you see we have shown the direction of the PL here. Then you can omit the azimuth.
Okay, sir.
Okay, great.
PL for star Y is going to coincide with the observed parallel of latitude. So here is the PL for star Y, which you can say should have been drawn through observed lat and DR long, but since it's east-west, so it doesn't matter whether DR long is marked or not. Now the two PLs being for the same time, they intersect here. So this becomes the fix of the vessel. And what do we see? The latitude of the fix is same as the observed lat. And this distance is the departure of the fix from the observed long. So we see that the departure is 1.1 minutes east from the observed long. So we come this side for calculations now. Fix lat is same as observed lat, 50 degrees 14 minutes south. Departure, read off from the plot using the same scale out here. From observed long to fix is 1.1 minutes east. We convert this departure into D long by using the cosine parallel sailing formula for latitude 50 degrees 14 minutes, and we get the D long as 1.7 minutes east. This D long we apply to the observed longitude, and that was 140 degrees 36 minutes east. When we apply a D long of 1.7 minutes east to it, our fixed longitude becomes 140 degrees 37.7 minutes east. So the coordinates of our fix obtained through plotting would be then 50 degrees 14 minutes south, 140 degrees 37.7 minutes east, and it's here that we have the fix of the vessel.
So beta, you see the question now. On the left hand side in the graph paper, we have the plot. This is exactly how the plot should be made on your answer sheet or graph paper. And all these items which are labeled in the plot, you see the scale is mentioned, you see whatever latitude and longitude is drawn, that value is mentioned, the departure which is picked up, that is mentioned. So all these things which are mentioned here should be there in your plot or your diagram also. In this question, the diagram or the plot is very, very important, because the whole question is based on the plot. So if it is not properly labeled, not well labeled, this results into a cutting of marks. So please make sure when you make the plot, it is well labeled. And on the right hand side, you see this working here. We have shown the working of how did we find the d long from departure. So this working which is shown should also be shown in your answer sheet. Sometime what the candidates do is they do this on the calculator, get the answer and straight away write the answer without mentioning the steps. So that may also sometime lead to loss of marks. So the information which you see on the screen is exactly the same information which should be there on your answer sheet. Now you can have a good look at the question. Any doubts coming in, please let me know.
सर एक छोटा सा कंसेप्ट बता दीजिए सर जो आपने जीसी में बताया था एक्चुअली सर ये जब हम लोग डी लॉन्ग फाइंड आउट करते हैं सर फ्रॉम टू लॉन्गिट्यूड्स डायरेक्शन तो उसका डायरेक्शन ठीक है सर वो तो क्लियर हो गया था सर ये इसमें कंफ्यूजन होता है कभी कभी जब हमारे पास डी लॉन्ग होता है और दूसरा लॉन्गिट्यूड फाइंड आउट करना होता है सर उसके डायरेक्शन में वो एक बार बता दीजिए सर
ओके बेटा, बस एक चीज याद रखना अपने माइंड में कि जो ये प्लॉट आप देख रहे हो, इस प्लॉट में जो राइट हैंड साइड है वो ईस्टर्ली डायरेक्शन है, राइट बेटा?
ओके सर।
और लेफ्ट हैंड साइड जो है ये वेस्टर्ली डायरेक्शन है।
यस सर।
राइट, बाकी सब भूल जाओ, कोई कंफ्यूजन नहीं होगा।
नहीं इसमें नहीं सर, जीसी वाले क्वेश्चंस में भी होता है सर कंफ्यूजन। सेम जब हमारे पास डी लॉन्ग होता है, एक पी की वैल्यू आ जाती है और एक लॉन्गिट्यूड होता है और दूसरा लॉन्गिट्यूड निकालना होता है सर।
नो प्रॉब्लम बेटा, जो सबसे ज्यादा कंफ्यूजन जिस क्वेश्चन में हो रहा है उसे पिक कर लेना। आफ्टर वी फिनिश वी विल डिस्कस इट ऑन द व्हाइट बोर्ड।
ओके सर, ओके ठीक।
ओके बताओ बेटा। दैट्स राइट। ओके बेटा, ओके आई गॉट इट बेटा। अब ध्यान से सुनो बेटा, जब भी आप डिपार्चर डीलोंग का फॉर्मूला यूज करते हो तो यहाँ पे कॉस ऑफ मीन लैट होता है। अब कभी कभी आपके प्लॉट में 2 लैटीट्यूड, 3 लैटीट्यूड, 4 लैटीट्यूड, बहुत सारे लैटीट्यूड हो सकते हैं। सो कभी कभी कंफ्यूजन होता है कि मीन लैट कहाँ से लेना है, कौन से 2 लैटीट्यूड्स का मीन लेना है। लाइक हियर ऑल्सो वी हैव 50-10 एंड 50-14। अगर इन दोनों का मीन लेंगे तो 50-12 आता है। सो कैसे ले इसको, ध्यान से सुनो बेटा। व्हेनेवर यू आर फाइंडिंग द फिक्स, आपको डिपार्चर चाहिए, आपको डीलैट चाहिए, you will be finding the fix from a reference position on your plot. एक कोई रेफरेंस लैटीट्यूड यूज करोगे आप और एक कोई रेफरेंस लॉन्जिट्यूड यूज करोगे आप। आपको वो रेफरेंस पोजीशन को आइडेंटिफाई करना है एंड दैट रेफरेंस पोजीशन एंड योर फिक्स, इन दोनों का मीन आपको निकालना है। आई एम रिपीटिंग इट वंस अगेन। सबसे पहले रेफरेंस पोजीशन को आइडेंटिफाई करना है, रेफरेंस पोजीशन और फिक्स का मीन लैट लेना है। नाउ इन दिस क्वेश्चन द रेफरेंस पोजीशन विच आई एम यूजिंग इज द ऑब्जर्व्ड लैटीट्यूड। मुझे और कोई लैटीट्यूड चाहिए ही नहीं बिकॉज मेरा तो फिक्स लैट ऑब्जर्व लैट ही है। एंड लॉन्जिट्यूड विच आई एम यूजिंग इज द ऑब्जर्व लॉन्जिट्यूड। सो दिस इज माई रेफरेंस पोजीशन वेयर द कर्सर इज राइट नाउ। नाउ रेफरेंस पोजीशन एंड फिक्स पोजीशन दोनों का लैटीट्यूड सेम है, मैंने सेम लैटीट्यूड यहां पे यूज किया है। डज दैट मेक इट क्लियर?
सर वंस मोर अगर चेंज होता तो क्या करने का फिर सर? द फिक्स लैट वुड हैव बीन डिफरेंट देन व्हाट टू डू, मतलब ये क्वेश्चन में
ओके बेटा, आप ये समझ गए कि हमें रेफरेंस लैटीट्यूड और फिक्स लैटीट्यूड का मीन लेना है।
यस
राइट। सो अगर फिक्स लैटीट्यूड डिफरेंट होता तो मैं फिक्स लैट का और रेफरेंस लैटीट्यूड का मीन निकाल देता बेटा। अभी आगे क्वेश्चन आएंगे जहां हम ये करेंगे।
ओके देन हाँ चले, आई अंडरस्टैंड। ओके
राइट। अब एक और चीज सुनो बेटा, इसके बाद जो मैंने अभी बताया है इसके बाद एक और चीज सुनो। अगर जो मैंने अभी बताया है ये आपको याद नहीं रहता है और कोई बंदा जो है वो 50-10 और 50-14 का मीन लैट 50-12 ले लेता है, 50-12, आंसर उसका फिर भी सेम ही आएगा, बिकॉज व्हेन यू टेक द कोसाइन this much of difference in latitude is not going to make any substantial difference in your answer. So आपको इसमें ज़्यादा कंफ्यूज नहीं होना है। अगर समझ में ना आए तो जो भी दो लैटिट्यूड दिख रहे हैं उनका मीन अगर ले लिया जाए आंसर में कोई फर्क नहीं आने वाला प्रैक्टिकली। अगर कोई 50-10 की जगह 50-14 की जगह 50-10 भी ले लेता है, न्यूमेरिकली आंसर में कोई प्रैक्टिकल डिफरेंस नहीं आएगा। So if you get confused sometimes, whichever latitude you take are going to give you the same answer. अगर आपको ज्यादा डाउट है यहाँ पे सिर्फ cos of m lat लिख दो और यहाँ आंसर लिख दो, it will give you the correct answer still. Clear बेटा?
It won't be counted as principal error, correct?
जब आपने वहाँ कोई latitude ही नहीं लिखा और m lat लिख दिया, so how it can be a principal error बेटा?
नहीं सर, जैसे आप कह रहे हो जब ऑलरेडी
करेक्ट
मिल गया है एंड वी स्टिल वी आर टेकिंग मीन लैट, इन दैट केस इट्स डिफरेंट।
No, it will not be. It will not be.
Yes sir, correct. I just calculated. It's not much fun.
I know sir.
Go ahead बेटा।
जब दिया होता तो एक फॉर एग्जांपल एक डीआर लेट दिया हुआ और एक ऑब्जर्व लेट दिया हुआ, इन दोनों का मीन निकालते हैं। अगर दो ऑब्जर्व लेट दिया हुआ तो हम ऑब्जर्व लेट का मीन लेट निकालते हैं सर, डीआर को छोड़ देते हैं। जो मुझे पता सर, जो मैंने सेकंड मिनट के टाइम जो सीखा था ऐसे ही मैं करता
बेटा,
था।
नहीं, मैं दोबारा रिपीट कर रहा हूं बेटा, रेफरेंस पोजीशन और फिक्स इन दोनों का मीन लैट हमने निकालना है। रेफरेंस पोजीशन और फिक्स। रेफरेंस पोजीशन का मतलब है जिसको देख के आपने अपना फिक्स लैटिट्यूड निकाला है, जिसको देख के आपने डिपार्चर निकाला है और डी लैट निकाला है। रेफरेंस पोजीशन और फिक्स इन दोनों का मीन निकालना है। क्लियर? आगे और क्वेश्चन आएंगे, मैं उसमें इसको और भी दोबारा आपको स्ट्रेंथन कर दूंगा। बोलो बेटा।
सर one more note sir, this reference latitudes, reference position that you told now, is it intersection of one PL and one observed long? Is it right?
No
in all
beta,
cases?
it is very simple. It is very simple. आपके पास ये फिक्स आ गई ना बेटा, यहाँ पे प्लॉट में you can see the fix.
हाँ सर।
अब जब आपको फिक्स का लॉन्जिट्यूड निकालना है, you need departure from a particular longitude. आपने यहाँ ऑब्जर्व लॉन्ग से निकाला ना बेटा?
Yes sir.
जिस भी लॉन्जिट्यूड को आप डिपार्चर के लिए यूज करते हो वो आपका रेफरेंस लॉन्जिट्यूड है। जिस भी लैटिट्यूड को आप डी लैट के लिए यूज करते हो वो आपका रेफरेंस लैटिट्यूड है। इस केस में हमें कोई सेपरेट रेफरेंस लैटिट्यूड की जरूरत नहीं पड़ी है। सो फिक्स लैट इज द रेफरेंस लैटिट्यूड इटसेल्फ। ओके, जहां से आपने डिपार्चर निकाला वो आपका रेफरेंस लॉन्जिट्यूड, यहां से आप डी लैट निकालोगे वो आपका रेफरेंस लैटिट्यूड। क्लियर?
क्लियर सर, क्लियर।
वेरी गुड। सो चलें बेटा आगे।
Yes sir.
Very good.
I'll also take you quickly through the same plot if it was done without a graph paper. It's the same plot, same steps. I don't think they need any further explanation because it's a repeat, but only thing is now the plot is being done on a plain sheet. And you can see how the plot is coming up. The two parallels have come up. We have the observed long meridian coming up. We have the PL for X. We have the PL for Y. We have the fix being identified here. We have the departure here. And then the same calculations as in the earlier discussion being carried out to get the coordinates of the fix. So if you do not have a graph paper, then your plot shall be somewhat like this. Please do not forget to declare your scale in the plot It's very, very essential. So the whole idea of showing this one was that if you do not have access to the graph paper, you could have your plotting done this way, the way you see it on this particular slide, which is on display right now. One more example, using DR 12 degrees 20 minutes north, 180 degrees, simultaneous observations of two stars gave following results. Star X azimuth 220 degrees true, observed long 179 degrees 55 minutes east. Star Y azimuth 305 degrees true, intercept 3 miles towards. Find the vessel's position. I'm sure Star X, which is a repeat as far as the process of deployed for solving it is concerned, has been solved by Cron, as discussed in the previous case also. So therefore, for Star X, the PL shall be drawn through DR lat and observed long. Direction of the PL shall be perpendicular to the azimuth. Star Y, which gives us intercept, has been then solved by intercept method. The PL shall be drawn through ITP, intercept terminal point or intercept terminus point, and the direction shall be perpendicular to azimuth.
So beta, just go through the question. Any doubts coming in, please share.
No, sir.
No, sir.
Very good, beta. Great. Let's go.
Having identified the methods deployed and the positions through which to draw the PL, we can proceed further. We can see on the graph, we have drawn DR lat and DR long and assumed a scale out here. Obviously, these have been placed keeping in mind the question so that other meridians and other parallels of latitude, if required to be plotted, they have enough space to be plotted on the graph. Now, DR long is 180 degrees. Observed long by solving star X site is 179.55 minutes east. So if I have to plot observed long with respect to DR long, which has already been plotted, then the D long between the two, it's the D long between the two, which is 5 minutes west from DR to observed long. That means observed long shall be plotted west of the DR long. But the spacing has to correspond to departure. So we find the corresponding departure, and the departure is found to be 4.9 minutes west. We also identify the direction of the PL for star X, which is perpendicular to its azimuth, direction being 130 to 310. And likewise, direction of PL of Y, perpendicular to azimuth of 305 degrees true, and direction being 035 degrees to 215 degrees true. So now, using this departure between the two meridians, we plot the observed long. So here is the departure to the west, 4.9 miles, and here is the meridian for the observed long.
Okay, beta. So have a good look up to here. Let me know any doubts coming in.
सर ये ईस्ट वेस्ट डिस्टेंस हमेशा डिपार्चर से ही लेना है सर?
हमेशा बेटा, जब भी यहाँ आपको ईस्ट वेस्ट डिस्टेंस डालना होगा तो आप डिपार्चर ही डालोगे. जब भी आप यहाँ से रीड करोगे तो वो डिपार्चर ही आपको मिलेगा.
ओके सर, ऐसा नहीं है कि ये 5 डिग्री वेस्ट है तो 5 वेस्ट करके ऐसा?
नहीं बेटा, ऐसा इसलिए नहीं है क्योंकि ये जो प्लॉट है इसमें हम लॉन्जिट्यूड स्केल यूज ही नहीं कर रहे हैं. हमारा सिर्फ एक ही स्केल है, वो है लैटिट्यूड स्केल.
ओके सर.
So clear up to here बेटा, चलें आगे?
Yes.
Very good.
Now wherever the DR lat intersects the observed long, this is the point through which the PL for star X has to be drawn, and its direction is 130 to 310. So here is the PL for star X which comes up on the plot. PL for star Y would be drawn through ITP. So first we draw the azimuth through the DR. Azimuth of star Y has been drawn through the DR. Now intercept is 3 miles towards. That means it will be 3 miles on this line towards the body. We mark off 3 miles here. This green line showing up here measures 3 miles. So this is the point which is the ITP. Through this point we draw perpendicular to the azimuth and we get the PL for star Y. Since both the PLs are for the same time, therefore this is where the fix is. We read off the D lat for the fix from the DR lat, which is 0.7 minutes south, and likewise we also read off departure, which is 0.8 minutes east of the observed log.
So beta, any doubt up to here?
No, sir.
Very good, beta.
Using this D lat and departure, we come on this side. We have the DR lat. We know the D lat of the fix from the DR lat, and we get the latitude of the fix as 12 degrees 19.3 minutes north. We have the departure of the fix from the observed long, which is 0.8 minutes east. We convert this departure into D long. So D long comes to 0.8 minutes east. So that means longitude of fix is 0.8 minutes east of the longitude, observed longitude.
Now beta, here let me explain. This latitude which they have used, cos of 12 degree 20 minutes, is basically the mean lat between the fix and the reference latitude. In our case, it will be the mean of 12 degree 20 minutes and 12 degree 19.3 minutes. So that is actually 12 degree 19.7 minutes. So it's rounded off to the nearest minute. So again comes at 1220.
Observed longitude being 179 degrees 55 minutes east. The longitude of the fix is then 179 degrees 55.8 minutes east. And hence, the coordinates of the fix are 12 degrees 19.3 minutes north, 179 degrees 55.8 minutes east.
Okay, beta. So we have the question now solved. Have a good look. Let me know your doubts.
Hello, sir.
Bolo, beta.
Hello, sir. Sorry to disturb you, sir. I was not able to connect. Now, fortunately, I am able to connect now. So, sir, I don't understand what is this actually.
Okay. तो बेटा अभी तो जो चल रहा है उसे चलने दो बेटा, यहाँ से आगे कैच ऑन करो एंड जो तुम्हारा मिसिंग पोर्शन है दैट आई विल कवर अप, डोंट वरी.
कोई नहीं सर, हम लोग डिस्कस कर लेंगे.
ओके ओके, थैंक यू.
नो प्रॉब्लम, यू कैन डिस्कस. अगर स्टिल डाउट हो तो आई विल कवर अप, डोंट वरी.
ओके सर, नो प्रॉब्लम, थैंक यू.
Okay.
Yes, sir. So can you just hold on to the screen for next at least 2-3 minutes because this process is just 2-3 minutes.
No problem, beta. Take your time, see it. Any doubts coming, please share with me. Let me know once you are comfortable. But don't start making a plot in your notebook, beta. That will be too long. Huh? You can do that after the class.
No, sir, no, sir. I am just looking at the figure.
Just have a good look. Any doubts coming in, share.
एक्सक्यूज मी सर.
बोलो बेटा.
सर ये कैलकुलेशन हम डीआर लेट और ऑब्जर्व लॉन्ग से भी कर सकते हैं ना सर?
यस, दैट्स राइट बेटा. अब ये जो फिक्स हमने निकाली है इसके लिए हमें एक रेफरेंस लैटिट्यूड और एक रेफरेंस लॉन्जिट्यूड चाहिए. सो इफ समबडी वांट्स इंस्टेड ऑफ ऑब्जर्व लॉन्ग ही कैन यूज द डीआर लॉन्ग आल्सो, दैट कैन बी डन. बट ऑलवेज प्लॉटिंग में ये रिकमेंडेड होता है कि आप वो वाला लैटिट्यूड और लॉन्जिट्यूड यूज करें विच इज क्लोजेस्ट टू द फिक्स. that gives you more accuracy. So that's why the observe long is used.
Sir, is this applicable also to latitude? Like if there are two latitudes, then we take which is the closest.
That's right, beta. If there are two latitudes which you can use the one which is closer. If you use the other one also, that would not be wrong. That would also be correct. Only thing is the accuracy may suffer. That's all. So pick up the nearest one.
Okay, sir.
Sir, likewise, we started in the beginning of this lecture where you mentioned that there are two types of questions wherein if the distance is more than 10 miles or something, then we have to calculate it.
That's right, beta. I'll show you that type of question also later on.
Okay, okay, sir.
I'll show you.
Okay, sir. Please continue.
You should be using MLAT, but as I told you, even if you use a simple latitude, any of the latitudes in the plot, the numerical answer is going to be the same.
So in this question, there is no anything about MLAT because it's on DRLAT only.
Yeah, you should actually be taking 12 degrees, 19.7 minutes here.
How, sir?
Okay.
So here, only one latitude is the question.
Go ahead, beta, one by one.
So in this question, we have only got. So in this question, we have got only one latitude, right? So how can we take mean lat here?
Beta, I told you take the mean of reference latitude and fixed latitude. Reference latitude is 1220, fixed latitude is 1219.3, mean is 12 degrees 19.65, which is 19.7.
Answer will be same only. Okay.
That's right.
So, yeah.
Exactly, beta. That's right. Okay,
sir,
beta.
In this type of question, sir, 1 minute, sir.
Bolo ji, bolo.
So in this question, we need to understand before commencing that answer that in intercept method it will be always dr long and dr let, and in long by cone method it will be observed long, right? Sir?
Yes, beta, certainly that is very, very important. That is very, very important. You should know all the 5 methods, how the position line is plotted. That's why when we did the methods, for every method I showed you the diagram. So it is very important that you have clarity, because if that is not known, तो question गलत हो जाएंगे बेटा.
Yes, sir. So that's important. Okay.
Yes. So let's move.
So just one thing. I quickly plotted this just now as we were discussing. I quickly plotted all this, but yes, the answer is coming correct.
Great, beta. Very good then. Let's move ahead.
Now, if you do not have access to the graph paper, the same plot shall appear the way you can see on a plain sheet here and drawn to a scale that is chosen. And that's how your plot shall appear on a sheet in the absence of being plotted on a graph paper. Let's have one more example then. On 15th June 1992 at GMT 12 hours 05 minutes, the true altitude of the sun was found to be 89 degrees 55 minutes. At the same time, a point of land in position 23 degrees 26.5 minutes north, 001 degrees 15 minutes west, bore 320 degrees true. Find the position of the vessel if the sun passed north of the observer.
So beta, before we go into this question, now you have done position circles in chart work. One of the methods of getting a position circle is high altitude observation. So you remember how the high altitude observation position circle is plotted? What is the center of that circle?
The geographical position.
The
That is the
geographical
declination
position
and
of
the change.
the celestial body.
Great, beta. Excellent. So GP of the body is the center. And can you tell me what is the radius?
So radius will be the true zenith distance.
Great, beta. Excellent. Right. So you can see here we have a high altitude observation, 8955. So we will be using the same concept here. Now you can read the question. Any doubts coming in the question, please let me know. Okay, so looks like everybody is okay. So I'm proceeding ahead.
Now, in this case, the celestial observation shall not give us a PL because it's a high altitude observation with altitude of 89 degrees 55 minutes with a TZD is only 5 minutes. Therefore, in this case, the sun observation shall give us a position circle by the method that we have discussed in our earlier videos as PC by high altitude celestial observation. The second case is of a PL by bearing of a identifiable point on land, so that we are all conversant with. Now, first we need to get the GP of the sun to be able to get the PC, because when you have a PC by high altitude celestial observation, then the center of the PC is the geographical position of the body on the surface of the earth, and the radius of the PC is equal to TZD. And what is geographical position of a body? Geographical position of a body is linked to its declination. The latitude of the GP is same as the declination of the body, both in name and value and name. The longitude of the GP is related to the GHA of the body. If the GHA is less than 180 degrees, the longitude of the GP is same as the GHA, and the longitude carries a westerly name. If the GHA happens to be more than 180, then the longitude of the GP is 360 minus GHA, and the longitude shall be named east. We first, to be able to get the GP, we get the GHA of the sun and we get its declination. So we have this as the GMT. From the almanac, we start getting the GHA and declination. Then we have the increment for GHA and decorrection for the declination. We get GHA of sun and we get declination of the sun. From here, what do we infer? That the GP's latitude shall be north 23 degrees 19.9 minutes, same as the declination of the sun. And as the GHA is less than 180, so the longitude of the GP shall be same as the GHA, and the longitude shall be named as west.
So up to here, if any doubt is coming, please let me know, beta. Great. So let's go ahead.
So I hope you are able to recall how the GP is obtained. Now what we have drawn on the graph is the parallel of latitude for the land, the point on land, which is 23 degrees 26.5 minutes north. Why? Because we see that the GP latitude is south of it. Now this is here that we are drawing the meridian for the point on land, which is 001 degrees 15 minutes west, and we know the meridian of the GP shall be to the east of it because its westerly value is lesser. So that's why they have been drawn, one right on top almost and other to the left part of the page. Now we have this obviously is the landmass, the point on land whose bearing has been taken as to give us the second PL. Now we can, since the distances involved are little bigger, we can have a little smaller scale, 1 centimeter equal to 2 minutes or 2 miles. Now the land point to GP, DLAT is 6.6 minutes south. That means the parallel of the GP shall be 6.6 minutes south of it. And since we have chosen this scale of 1 centimeter equal to 2 miles, so this is where we have the parallel of latitude for the GP of the sun. Now we find out the D long from the point on land, this meridian, to the meridian of the GP, and the D long is 7.4 minutes east. That means meridian of the GP on this would be on this side. But to space them out, we'll need the departure. So the departure using the latitude, we get departure as 6.8 minutes. So using the same scale of 1 centimeter is equal to 2 miles or 2 minutes, we come 6.8 miles to the east, minutes to the east, and we are able to plot the meridian of the GP. Where the meridian of the GP intersects the parallel of the GP, obviously this is the point where we have the GP of the sun.
So we have plotted both the reference positions, beta, the land point and the GP of the sun. Any doubt up to here, beta?
Sir, if I mind you, sir, can you play the last 1-2 minutes of the video? I had got a call on somebody, so I missed it, sir. Just from the time when the positions were plotted, if you can.
Beta, can you have a look here? Everything is there on the screen, what we discussed. Just have a look, and wherever doubt is coming, please share with me.
Okay, sir.
Okay, all right. So let's proceed ahead.
Now we come to plotting of the PL and PCs. Now this is where we have the PL by bearing. This land point is bearing 320 degrees. So this becomes a PL of the vessel. Now we also know that the true altitude is 89 degrees 55 minutes. So TZD is only 5 minutes, which becomes the radius, 5 miles becomes the radius of the circle. So with this GP as the center and 5 miles as the radius, we draw the position circle, and this is the position circle of the vessel. Since this PC and the PL are for the same time, the vessel could be at the point of their intersection. So the vessel may be either at this point, that is point A, or maybe at this point, point B.
Okay, beta. So we have drawn the position line, we have drawn the position circle, we have got 2 intersection points. Up to here, any doubt, please share with me.
Yes, sir. I have little doubt this position line. How we draw in position circles? Just I missed out this position radius of 5 mile.
Okay. So
and
can you
center taken the
can you
sun's GPY, sir?
Okay, beta. Beta, do you know about high altitude observation?
No, sir. No idea.
You have attended position circle lecture in chart work?
No, sir. I missed that lecture.
Okay. Now there is a free video in Marine Gurukul. उसका लिंक बेटा आई थिंक अपने ग्रुप में भी किसी ने शेयर किया हुआ है. So just watch that video on position circles. उस वीडियो में जो लास्ट पार्ट है उसमें हाई एल्टीट्यूड ऑब्जर्वेशन एक्सप्लेन्ड है. So just have a look there, beta. You will be spending about 5 to 10 minutes and the concept would be clear.
Okay, sir. High altitude.
Okay. High altitude observation, position circle.
Okay, sir.
Right? If any doubt comes, once you watch the video, any doubt come, please share with me.
Okay, sir. Thank you, sir.
So this bearing line of what have we got, sir? I'm still lost a bit.
Okay, beta. Can you see this land point, beta, here? Land point?
Yes, sir.
Now, from the ship, this land point is bearing 320. Correct, beta? 320.
That opposite.
Yes, sir.
Right. So from the ship, it is bearing 320. Now, if I draw a line from this land point in the reciprocal direction, ship has to be somewhere on this line.
Okay, sir. Yeah.
Then only this will bear 320, beta. So that is what is done, beta. This is how we draw a position line when a bearing of a object is given. So comfortable, beta, up to here? Can we move ahead?
Sir, just 2 minutes, sir. Then we can.
Okay.
This position of the vessel will be at B, sir, right, sir?
अब ये तो क्वेश्चन अभी देखना है बेटा. बताओ कहाँ होगी, ए पे या बी पे?
ऑब्जर्वर बोला है ना सर उसने.
राइट.
Sir, we will be at B.
A, sir, A.
नहीं सर, we will discard A, क्योंकि अगर सन को नॉर्थ ऑफ ऑब्जर्वर होना है तो बी पे ही हो सकता है ना, बी से ऊपर सन है.
वेरी गुड बेटा. जो ये जीपी देख रहे हो आप, विच इज द सेंटर ऑफ आवर पोजीशन सर्कल, दिस जीपी, ये किस चीज की पोजीशन है बेटा? ज्योग्राफिकल पोजीशन
सन की. सन
की. So that means the sun is here. Sun is here.
Observer
right?
is down.
Yes, observer has to be south of the sun because the sun passed north of the observer.
North of observer.
So, correct position will be Bravo.
Yes.
Let me show you here also.
Now, since the question says the sun passed north of the observer, now sun in this plot is represented by its GP. So if the observer is at A, then sun is passing south of the observer. But if the observer is at B, the sun is passing right north of it. So therefore, in this case, position A gets ruled out. The fix is then position B.
Go ahead, beta.
Sir, had it been not mentioned here that they find the position if the sun has passed the north of observer. Otherwise, also we had to rule out the A because the altitude could be only when the body is above the observer. 9.9, 89.55. We are taking the side.
No, beta. If you are anywhere on this circle, the altitude of the sun would be 89.55. That is why it is a position circle, na beta?
Yes, sir. Okay, understood.
Okay. If you are at any point on the circle, the altitude of the sun at all the points on the circumference of the circle will be 89.55 only.
Okay, thank you.
Sir, one more doubt.
बोलो जी.
GP of sun का longitude sir west कैसे आ गया? How it comes? West?
बेटा आप एक बार उसकी वीडियो देखना, क्लियर हो जाएगा. मैं वैसे अभी ब्रीफली बता देता हूं. अगर आपका GHA 180 से छोटा हो तो लॉन्जिट्यूड वेस्ट होता है, और अगर आपका GHA 180 से बड़ा हो तो लॉन्जिट्यूड ईस्ट होता है.
ओके, 180 से छोटा हो तो ईस्ट होता है.
नो बेटा, 180 से छोटा हो तो वेस्ट होता है, बिकॉज GHA इज ए वेस्टर्ली मेजरमेंट.
वेस्टर्ली मेजरमेंट, यस सर.
और अगर 180 से बड़ा हो जाए तो लॉन्जिट्यूड ईस्ट हो जाएगा, एंड इट विल बी 360 माइनस GHA.
ओके सर. ओके सर, अंडरस्टूड.
ओके बेटा. सो चलें बेटा, आगे चलें। अब बेटा अगर हमें यहाँ क्वेश्चन में बोला होता कि ये हमारे पास ऑब्जर्वेशन है तो हम उसको यूज कर सकते थे, बट सिंस द क्वेश्चन डज नॉट मेंशन दैट, तो हमें नहीं पता है कि ये हमारे पास है या नहीं, सो वी हैव टू यूज इट बाय पोजीशन सर्कल ओनली बेटा। चलें बेटा आगे। Very good. Let's go.
So B is the fix out here. And what do we see in this case? That B lies on the same meridian as the meridian of the GP. So in this diagram, what do we see? This is the D-lat of the fix from the latitude of GP, and it's exactly 5 minutes south. So therefore, the latitude of the fix becomes 23 degrees 14.9 minutes north. What do we see about the departure? The fix lies on the meridian of Sun's GP, so departure from there is 0, therefore D long is also 0, and therefore the fix long is same as the longitude of the GP of the Sun, which is 001 degrees 07.6 minutes west, and therefore now the coordinates of the fix are 23 degrees 14.9 minutes north, 001 degrees 07.6 minutes west.
ना बेटा ये क्वेश्चन अगर आप प्रैक्टिकली प्लॉट करोगे तो आपका आंसर थोड़ा सा डिफर करेगा, बिकॉज इसमें एक छोटी सी प्लॉटिंग मिस्टेक है. सो इफ यू डू इट एंड योर आंसर डिफर्स फ्रॉम दिस वैल्यू, basically the longitude will have some difference. Don't worry, your solution will be correct. Okay.
Okay, sir.
Okay beta, great. So this was a good question. So चले आगे.
सर एक मिनट सर लिख लेते थोड़ा.
Okay beta, all right.
सर ये वाला भी वीडियो मरीन गुरुकुल पे है क्या सर?
Beta, this video is available there.
Okay sir. Thank you sir.
Paid hai.
So we expected this kind of questions in the exam, right?
That's right beta. शुरू वाले जो questions थे, that was just to familiarize you. This is a question, a type of question which comes in the exam.
Okay, thank
you. Okay बेटा, चलें आगे.
Yes,
Very
sir.
good. Let's go.
So here in this case, we had the intersection of a PL and a PC. PL was drawn from a terrestrial reference and PC was by high altitude celestial observation. Just quickly a repeat of the same process on a plane sheet, same question. So just repeating it if you have to plot it on the plane sheet. Steps are exact repeat, the difference being that instead of a graph, the plot is being carried out on a plane sheet and the plot shall appear the way it's coming up. We have position A and B coming up. Then we have the fix also identified now, and it takes us to the position of the vessel. And this is how the plot shall appear if you do not have access to the graph paper. Then this is how you would plot your question. We quickly run through the last example. DR 00 degrees 4 minutes north, 179 degrees 57 minutes east. Two simultaneous observations, star X, azimuth 120 degrees true, observed longitude 179 degrees 58 minutes west, star y azimuth 200 degrees true, intercept 2 miles away to find vessel's positions. I'm sure as far as methods are concerned, there is no discussion that should be required now. Star x by longitude by chronometer, star y by intercept method. On the graph, you can see up dr lat and dr long coming up. And now to be able to draw the observed long with respect to dr long, we find the d long from dr to observed long coming up on the right side here, 5 minutes east. We convert this d long into departure, and departure also happens to be 5 minutes east. Then we identify the direction of the PLs perpendicular to their respective azimuths out here. And now with the departure being 5 minutes east with respect to dr long, we mark off the departure here, 5 minutes east, and we draw the meridian of the observed long. Now through this point, which is intersection of dr lat with observed long, we have the PL for star x in the direction of 030 to 210, and you can see the PL of x coming up on the plot.
Now beta, before we proceed ahead, we have just plotted the two positions which were given in the question. So any doubt in this beta before we go ahead?
No, sir.
No, sir.
Very good beta, great. Let's go.
On the graph passing through this point. For PL of y, we identify the ITP first. So we draw the azimuth of y through the dr. Here is the azimuth in the direction of 200 degrees true. Now in this case, the intercept is 2 miles away. So we mark off 2 miles in the opposite direction, represented by this green line out here. So this is the ITP in the away scenario. Through this perpendicular to azimuth, we draw the PL, and this is the PL for y. Where the two intersect, this point is the fix of the vessel. We read off its d lat, it's 0.3 minutes north of dr lat, and its departure we read off here. This departure is 0.2 minutes east of the observed long. We apply this d lat to the latitude of the dr lat, and we get the latitude of the fix as 00 degrees 04.3 minutes north. Departure from observed long to the fix is 0.2 minutes east. We convert this into d long, and being almost at equator, they are both equal. We apply this d long to the observed long, which is 179 degrees 58 minutes west, and we get the fixed long as 179 degrees 57.8 minutes west. So the coordinates of the fix out here are 00 degrees 04.3 minutes north, 179 degrees 57.8 minutes west.
So we have the plot made now. Let me know any doubts coming in beta.
Sir, departure equals to d long into cos of latitude equals to 5 minutes लिखा हुआ है. यहाँ पे d long की वैल्यू 1 है और cos of 0 degree 4 minutes will come only 1 mile. That should be 1 mile east. अगर आपके पास कैलकुलेटर तो प्लीज चेक कर सकते हैं सर आप.
You mean the d long to departure conversion?
In the solution, fourth line from the top.
1, 2, 3, 4. D long into cos of m lat.
Yes, sir. Here the D long value is 1 minute, right?
5 minutes. 5 minutes.
Five minutes.
Look at the D long longitudes. One is easterly longitude, one is westerly longitude, beta.
Understood, sir. Understood.
Okay. So let me know once you are comfortable, beta. Then we'll move ahead.
ये क्वेश्चन 5 है या 6 है? Any question 5 or 6?
You mean to say how many questions we have done?
No, sir. In the exams, it is 5th question or 6th question.
Okay. बेटा एग्जाम में यूजुअली ये नंबर 6 पे आता है, बट इट इज नॉट फिक्स्ड. कभी कभी ये 5 पे भी डाल देते हैं. 5 और 6 ये दोनों जो सवाल हैं, इनमें से one question is supposed to be on site solving and the second should be on plotting, but interchangeable. 5 और 6 में किसी भी पोजीशन पे आता है बेटा.
साइट सॉल्विंग मतलब सर वही लॉन्ग बैकग्राउंड वगैरह जो हमने किया ना, वही ना.
That's right.
ओके सर.
So comfortable बेटा, चलें आगे.
So just 1 minute.
Okay.
Okay sir, comfortable sir. Okay, go ahead.
Okay beta, so I'm
One minute.
okay, you are still doing keep on doing beta. Let me know once you are done.
Take a break.
So we'll take a break and we'll complete this topic and then we'll knock off the class. Okay, sir.
Yeah, okay. ब्रेक मुझे इसलिए मैं इंटरेस्टेड होता हूँ बिकॉज उससे ना थोड़ा सा मुझे अलेज मिल जाती है टू फिल योर ब्रेन अप. ओके, इट शुड नॉट स्टार्ट ओवरफ्लोइंग, सो दैट्स व्हाई. सो टेक ए ब्रेक. सो वी हैड सीन simultaneous observations, both observations taken at the same time and plotted. Now we are going into staggered observations, observations taken at different times. Staggered question becomes little more detailed or lengthy because there is a transfer of position line which is involved. So we will be seeing some examples in staggered observations. जो पहला क्वेश्चन मैं आपको दिखा रहा हूँ बेटा, इसमें मैं आपको एक्सप्लेन करूंगा बेसिकली.
Is true for 100 miles when the latitude by meridian altitude of the sun at 11:55 ship's time gave an observed latitude of 51 degrees 10 minutes south. Find the vessel's position at 11:55 hours. I am pretty sure that if we were given a chart for this area, we could have easily transferred the AMPL to 11:55 and got the desired response. Now, in the absence of chart, let's try to create a small chart on our graph and do this question through an assumed scale.
First of all, beta, just go through the question. If any doubts are coming, let me know.
Okay, sir. Question is okay.
Great, beta. Let's see.
Now, in the morning site, obviously it has been solved by longitude by chronometer method. So the PL shall be drawn through DR lat and observed long. Direction of the PL perpendicular to azimuth shall be 165 degrees, 345 degrees. Why? Because the azimuth was 075 degrees true. Now, the morning DR lat is 50 degrees 10 minutes south. At 11:55, if you see the question, it has been solved by latitude by meridian altitude. So the observed lat is 51 degrees 10 minutes south, and we know that the direction of the PL in this case shall be east-west. So now we have D lat from DR lat to 11:55 observed lat, and the D lat is 60 minutes south. Direction of 11:55 PL, I've already said it's latitude by meridian altitude, so it's east-west. Now with this inference drawn out of the question, let's get going with the part plotting first. Here we have the DR lat 50 degrees 10 minutes south. We have the observed long 140 degrees 36 minutes east. Now this is the point through which the AMPL shall be drawn. The direction of this AMPL is 165 345. That is the AMPL for star X. Now we know that the DLAT from the DR lat to observed lat at 11:55 is 60 minutes south. So we have taken a scale wherein one box here of 1 centimeter represents 10 miles. So that way we account for 60 minutes of DLAT, and we are able to then plot the observed lat for 11:55. Now the PL at 11:55 is east-west, so it coincides with the observed lat, and here we have the PL for 11:55.
So beta, up to here, okay? Any doubt up to here?
Sir, we don't have a time for initial PL for long background.
No beta, they have just given the distance traveled. They have not given the time.
Okay, sir.
Okay, so let's go ahead.
Now we have two PLs, one for the morning time, second for 11:55. So to be able to deploy running fixed or staggered method, as we call it, we are calling it here now, we have to transfer this point, and we've learned that we transfer any point on the PL, first PL. And how do we transfer? We apply the run, we apply wind, we apply current, whatever is applicable in a given scenario. In this case, it's only the ship's own steaming. So point A is a point on the first PL. We draw the course of 120 degrees true, 200 miles, using the same scale which has been chosen here. And this takes us to point B. That means because of the ship steaming from morning side 11:55, point A on the first PL gets transferred to point B. That means if I have to transfer this PL now, this morning PL, which is in the direction of 165 to 345, it can be drawn through B, and we get this 11:55 transferred PL, which is the morning PL transferred to 11:55. Transferred PLs are represented by two arrows at each ends. Celestial PLs are represented by single arrow at their ends. Once they are transferred, then they are represented by two arrows. So this transferred PL is for 11:55. The second observed PL is for 11:55. Needless to say, where they intersect, this becomes the fix of the vessel at 11:55.
Okay, beta, have a good look up to here. Let me know any doubts coming in.
सर ये 100 miles is 10 centimeter on the scale, right? 10 centimeter scale पे मतलब draw करके just ये mark किए.
That's right, beta. A to B is 10 centimeters.
सर ये DLAT from AMDR to 11:55 observed lat 1 degree south कैसे आ गया सर?
Okay, बेटा. मॉर्निंग की जो बेटा DR थी वो थी 50 डिग्री 10 मिनट साउथ. दैट वाज द मॉर्निंग लैटिट्यूड 50 10 साउथ, राइट?
राइट सर, राइट.
एंड जो हमारा ऑब्जर्व लैट है वो है 51 डिग्री 10 मिनट साउथ.
यस सर, यस.
सो बेटा हम लोग 1 डिग्री.
ओके ओके ओके,
राइट,
1 डिग्री साउथ में.
यस, दैट्स राइट.
Yes. So from where that we have taken the observed lat 1 degree south.
That's right, beta. That's right.
Yes.
So now, sir, we have received this. It's on the observed lat, and we have departure. So again, same procedure, right? Departure to convert to D long and then final answer.
That's right, beta. I'll show you.
Correct.
Now, as far as the latitude of the fix is concerned, it's on the observed lat, so it is 51 degrees 10 minutes south. But this distance, east-west distance, we measure of the fix from observed long. We have done it in simultaneous plotting also. So this is the departure. So departure of the fix from observed longitude is 90 degrees east. We come on this side. Latitude of the fix is 51 degrees 50 minutes south. Departure from plot observed longitude fix is 90 minutes east. We use this latitude to convert this departure into D long. We get a D long of 2 degrees 22 minutes east. We apply this D long to the observed long. Why? Because this departure was from the observed long, so D long shall also be from here. So we apply this D long and we get the fixed long as 142 degrees 58 minutes east. And this way we have been able to get the position at 11:55 a.m. through this plotting of the two PLs which were staggered, and we just transferred the first PL to get our fix.
So this is the calculation beta. We have got the fix now. Up to here clear?
Clear, sir, clear.
Great beta, excellent. So चले आगे. Let's go.
Okay, so this is what we just solved. Do we see any problem with this working? Technically, none. But practically, yes. What is the issue here? Issue was that since the distances involved became larger, we had to compromise on this scale here. This scale, which in simultaneous plotting was 1 centimeter is equal to maybe 1 or 2 miles, had to be compromised to 1 centimeter representing 10 miles. That means the scale chosen had to be compromised upon. It became too small. The least count becomes small, and obviously the accuracy to read results also would then be compromised. So other than that, there is absolutely no problem whatsoever with this particular working. But then whatever is this limitation, it's also a serious limitation. The issue about this small scale can be resolved by reducing the scope of actual plotting and maybe performing part of the question numerically or mathematically on the answer sheet. What do we need here? We actually need to know the coordinates of point B through which the first PL has been transferred. So we could consider solving this part of the question mathematically by plane and parallel sailing so that we can get the coordinates of point B. Once we get the coordinates of point B mathematically, which means we get a point through which to draw the transferred PL, direction of the transferred PL shall be same as the direction of its PL in the morning, then that means we can now plot directly the transferred PL and we do not need to reference it to this point A out here. Why? Because all this has been mathematically then done. Once we have this point B coordinates through which to draw the transferred PL, we also have the second PL, transferred PL and second PL being of the same time, then this part of the plot, which is in the yellow box, can be plotted. And though you will be plotting a transferred PL and the second PL, but since they are for both same time, so the concept shall be exactly the same as you had done during the simultaneous observations.
So this is what we will be doing now, beta. The first part was just to show you the limitation in plotting. So now we will be doing it exactly as shown. So I hope it is clear.
Sir, last part,
Yes, sir,
sir, I
clear,
have
sir, clear.
confusion, sir. Can you explain how it is came two PLs?
Explain your doubt, beta.
Sir, I'm not getting how it is the two PLs on the B point B. I just miss
Okay,
out
beta. Okay. Now you see for 11:55 we have a observed latitude 5110 south that is given in the question.
Yes, sir.
And we had this morning long by Crone PL. After obtaining the morning long by Crone PL, we have steered 120 and 100 miles distance. So we have transferred this morning long by Crone PL by using this course and distance 120 degrees 100 miles and obtained point B.
Yes, sir.
Now, if you draw a line parallel to the initial PL passing from point B, it will give you a transferred position line, right? Right, beta? Got it up to here?
Yes, sir. So that line will coincide with the observed light. That will be the fix.
That is right, beta. So you have a transferred PL, which is now transferred to 1155. You have a observed lat, which is referring to 1155. Wherever they intersect will be the 1155 fix.
Yes, sir. Understood, sir. Thank you.
Very good.
So the
now,
only thing is that point B and 6 are of the same time of 11:55. That's why we are solving by simultaneous. Is it correct?
That's right. Exactly, beta. Once you bring them to the same time, you can solve it exactly as a simultaneous observation. So let me show you the calculation now. We have seen the green color part. We will be doing it by plane and parallel sailing. And the yellow color part we will be plotting on the diagram. So let us work out the green part by calculation and see.
So now let's solve the first part of this question mathematically to get the coordinates of point B, and thereafter only do the plotting of the limited portion, that is the second part of it. We know that the course from A to B is 120 degrees true, which in quadrantal notation is south 60 degrees east, and the distance is 100 miles. Using the plane and parallel sailing formula, we get d lat from A to B as distance into cosine of course, which comes to 0 degrees 50 minutes south. Please do keep calculating if you have any doubt as the video is playing. Latitude of A is already known to us, that is the dr lat, and the d lat from A to B is 0 degrees 50 minutes south. So we apply this d lat to this one and we get the latitude of B as 51 degrees 00 minutes south. We can also get the departure from A to B, that is distance into sine of course, and departure comes to 86.6 minutes east. Why east? Because our course in the quadrantal form was in the southeast quadrant, so d lat was south and departure is east. Now we can convert this departure into d long using the parallel sailing formula. D long will be equal to departure upon cos of lat or cos of m lat, depending on as the case may be, and we get d long as 136.4 minutes east, which translates to 2 degrees 16.4 minutes east. We know the longitude of A, which is same as the observed long, and we apply the d long to it and we get the longitude of B as 142 degrees 52.4 minutes east. So by applying the plane and parallel sailing formulae, we have been able to get the coordinates of point B. So now point B coordinates are known. We know the direction of the transferred PL, that has to be same as the morning PL, that is 165 to 345 degrees true. We know the second PL has to coincide with this parallel of latitude because its direction is east-west. So now we have two PLs, one drawn through this point B with the direction being 165 degrees to 345. Second one being drawn by latitude by meridian altitude method, direction being east-west.
So we have used the plane and parallel sailing to obtain point B. So we can now directly plot point B in our diagram and no need to show point A in our diagram now. So any doubt in this calculation, beta?
अच्छा अभी सर ये जो ग्रीन वाला पार्ट था हमें ये शो करने की जरूरत नहीं है, बस डायरेक्ट अब साइमल्टेनियस शो होगा ग्राफ में, आंसर में, एग्जाम में.
That's right, बेटा. जो छोटा बॉक्स देख रहे हो आप नीचे बॉटम राइट में, this is what we will be making it in the plot now.
ओके सर, बाकी चीजें आंसर शीट पे रहेंगी, कैलकुलेशन जो किया है हमने.
That's right, beta. The calculation will be on the answer sheet, and ये जो छोटा वाला block है, this will be part of our diagram.
So generally, what is followed, sir? Doing like this or doing with the graph, or like before?
This is what is followed, beta. देखो distance 100 miles आ गया ना यहाँ पे, और scale बहुत बड़ा हो गया था. So we never use this big scale. We always use as small a scale as possible. अब जब ये छोटी diagram बनाएंगे, तो हमारा स्केल बहुत छोटा हो जाएगा बेटा. It will not be 1:10. It will go maybe up to 1:2 or 1:3 maximum.
Okay, sir. So exam में सर यही करना है सर, समझ गया.
Exactly बेटा. Okay, so we have the B position. Now we have the information to make a simultaneous plot. Let's make it.
Now having got the point.
Okay बेटा. Holding.
अरे यार फोटो ले लो ना.
सर इसमें डीएमपी वाला तो जरूरत नहीं पड़ेगा ना हमेशा वो
से लिखने दो.
नहीं बेटा, इसमें आपको डीएमपी की ज़रूरत नहीं पड़ेगी क्योंकि इन क्वेश्चंस में जो डिस्टेंस होगा वो सर्टेनली 600 माइल से कम ही रहेगा. सो डीएमपी विल नॉट बी रिक्वायर्ड.
ओके सर, थैंक यू.
Okay sir, we can move sir.
ओके बेटा.
एक सेकेंड. ओके सर.
चलें बेटा. Shall we move? Okay, let's go.
Direction being east-west. Now having got the point through which to draw the transferred PL, that is point B at 11:55, and also having enough information to be able to plot the 11:55 observed PL, we can now get the position at 11:55. Now delat from the latitude of point B, which is 51 degrees south, to observed lat, which is 51 degrees 10 minutes south, is 10 minutes south. And we now come to the plotting out here. We have the latitude of point B on the screen. Now we choose a scale of 1 centimeter representing only 2 miles. Remember, compare it to the, when we were plotting the full question, we had to compromise on the scale 1 centimeter representing 10 miles, which has now improved to just 2 miles. We have this as the longitude of B. Obviously that gives us point B on the graph or the plot. Now, with respect to latitude of B, we draw the observed lat 10 miles south of it using the scale chosen. Now through B, we draw the transferred PL, and transferred PL is for 11:55 and represented by 2 arrows at each end being the transferred PL. We draw the 11:55 PL by latitude by meridian altitude, and that comes up on the screen. You all know about it. And being celestial PL represented by single arrow at each end. Now both these PLs are for the same time, so obviously now you know the procedure. This will be the fix of the vessel at 11:55. Latitude is directly available on the plot. It's same as the observed lat, but we can also read off this departure from observed long to the fix. It's 2.7 minutes east. It can be much better read now with a better scale. And now we perform the same calculations as you would have performed in simultaneous observations. The calculations are coming up on the screen. You can see for yourself. We can convert the departure of 2.7 minutes into D long, apply it to the longitude of B, and what we get is the longitude of the fix. And this way we are able to get the 11:55 hour coordinates for the vessel, which happen to be 51 degrees 10 minutes south, 142 degrees 56.7 minutes east. So now we can see that in case of staggered plotting, if the distances involved are large, if they are small, it can be graphically closed out. There's absolutely no problem. But if graphical representation is leading us to a compromise on scale, then that can definitely be avoided by performing part of the question mathematically and then only plotting the relevant part, wherein you deploy the same process as you have learned in the simultaneous observations.
So we have completed this plot now. So just have a good look. Let me know any doubts coming in.
ये तो वही सेम ही है सर जो पहले क्वेश्चंस किए वैसे ही डालना है.
Exactly, beta. Once you understand the concept of transferring using the plane and parallel sailing, so then the question becomes simple. Then it is a simultaneous question. So आगे अभी थोड़े और आएंगे. We will see more questions. So if you are comfortable, shall we move ahead?
Yes, sir.
Yes.
Yes, sir.
Okay, let me know once you are done. Okay, beta. Let's go.
Let's apply what we have learned to solve a few questions. In DR 17 degrees 41 minutes south, 179 degrees 50 minutes east, an intercept of 12.2 miles towards an azimuth of 081 degrees true was obtained by a stellar observation. Vessel then steered a course of 124 degrees true for 81 miles through a current setting 221 degrees true, drift 12 miles, when meridian altitude of the sun gave an observed latitude of 18 degrees 40 minutes south. Find the position of the vessel at the time of second observation.
So first you have a good look at the question, beta. Go through it. Let me know any doubts. Okay, great. So looks like clear. Let's move ahead.
Now, our first observation obviously is by intercept. So we need to get the position through which to draw the PL and also the direction of the PL. But to be able to see through the question, it's important that we make a rough diagram for this question and then figure out which part we have to calculate mathematically and then eventually perform the plotting part. So here we have the DR which comes up here, the time of first observation. Azimuth that time is 081, comes up on the screen. Intercept is towards, 12.2 miles towards, represented by blue line. This is the ITP, and here you have point X as the ITP, and you get the first PL. Now, vessel is somewhere on this PL passing through X at the time of morning, or the first observation rather. Now, what do we do then? Now we have to apply the run and the current. We allow for current. So we take any point on the first PL, and obviously point X stands out by default, being the ITP. So we apply the ship's run from X. We apply this course of 124 degrees for 81 miles, and that gives us the point Y. Now all this plot is not to scale, it is rough plotting. At Y we apply the current 221 for 12 miles, and we get point Z. From chart work knowledge we know X to Z is our CMG and distance made good, CMG and DMG. Now we know that point X stands transferred to point Z. So point X, through which the first PL is drawn, is now transferred to point Z. That means if we can mathematically calculate point Z, provided we know the coordinates of point X. But we do not have the coordinates of point X. On the contrary, we have the coordinates of this dr. But we know the direction of X and the distance. So if if you see, if I have to see from this DR and I have to come to point Z, then this is one leg that needs to be done. This is the second leg, and this is the third leg which has to be covered. So instead of, you see, there could be two ways of doing it. One is you calculate the coordinates of X, but that is again going to be time consuming. If we just put all these three legs together using the day's work concept, which we are all very familiar with, we can directly get the coordinates of point X. So this diagram is not to the scale, but let's see now if we work out the coordinates of X. This table we are all very familiar in the day's work. So in the remarks, we have the first would be this intercept leg. Why? Because why we are using this intercept thing here is, though this is before reaching the PL, but this is because we know the coordinates of the DR. So we have DR to ITP. The course will be 081 degrees, which is north 81 east. Distance will be 12.2 miles. We'll have northerly DLAT, easterly departure, which you're all familiar with. Second leg would be the vessel steaming on a course of 124 degrees true, converted to quadrantal, distance 81 miles, and obtained the departure, DLAT and departure. And the last is the effect of current, 221 degrees, converted to quadrantal, 12 miles the drift, and we get DLAT and departure. Then we total up the DLAT and departure in each column, and we get total. And using the values in the two columns, we get the resultant of DLAT and departure. So we get resultant DLAT of 52.5 minutes south. This resultant DLAT is the DLAT from DR lat to latitude of point Z. And our point of interest is point Z. As long as I can get the coordinates of point Z, I am not interested in the coordinates of point X. And departure from DR to Z is 71.3 minutes east. We know then what to do. DR lat is known to us, 17 degrees 41 minutes south. DLAT we have just obtained to point X, and we apply, we get the latitude of point Z. So we have got the latitude of point Z. We obtain the mean lat between DR lat and Z. We convert the departure into DLAT. Sorry, we convert the departure into D long, my mistake. And the D long comes to 1 degree 15 minutes east. We apply this D long to the DR long, and that shall give us the longitude of Z. And therefore, at the end of this working, we are able to obtain the coordinates of point Z. So that means when I go to the graph, I don't have to plot the DR, I don't have to plot this first PL, I don't have to plot this triangle. I can straight away come to point Z and transfer this first PL through point Z.
So let's take a pause here, beta. See the rough diagram and the calculation. Let me know any doubts coming in.
So how I have some problem in the how to find the latitude Z. Is it?
What problem are you facing, beta?
So I'm not getting how we get the latitude of Z positions. Is it?
Okay, beta. Okay. First of all, you see, beta, there are three legs. We are starting from the DR position. First leg is DR to ITP. This is the leg, right? DR to position X, correct?
Yes.
Then we have the second leg from X to Y. That is our course steered 124 into 81 miles. This is the second leg. And the third leg is the current Y to Z. So basically, अगर हमें ये तीन courses और distances apply करें हम DR position पे, we can reach up to the position Z. Do you agree?
Yes, sir.
Okay. So what have we done? हमने ये टेबल बनाया. इस टेबल में हमने इन तीनों लेग्स को यहाँ पे लिखा. हर एक लेग का डीलैट और डिपार्चर हमने निकाला यूजिंग द प्लेन एंड पैरेलल सेलिंग. डीलैट इज इक्वल टू डिस्टेंस cos course, departure is equal to distance sin course. So you see on the first leg the northerly departure is 1.9. Second leg the departure is southerly, so it is written under the south column, so that is 45.3. And for the third leg, the current leg, it is 9.1 south. हमने इन तीनों को ऐड किया. Okay, once you add them, the bigger value is 54.4, smaller is 1.9. So the smaller one is subtracted and you get the answer as south. The naming is the naming of the bigger value. Now this 52.5 is the DLAT between the DR position and the Z position. So up to here is clear, beta?
Yeah, that's what I'm confusing. So how
One
is
thing.
DR, I mean, from DR to Z, how it will be saying?
DR let add करेंगे.
No, beta, I
Sir,
didn't get you. Can you speak
first
again?
DR to ITP.
हाँ, that's right.
ये क्यों लिया है सर? ये समझ नहीं आया.
Very good, बेटा. हम ये नहीं लेते हैं, हम इसको छोड़ देते हैं क्योंकि हमें तो x पॉइंट को ट्रांसफर करना है z पे, करेक्ट?
Yes, looks like yes sir.
वेरी गुड. सो हम जो है dr को बिल्कुल छोड़ देंगे, हम इसे लेंगे ही नहीं. हमने तो x पॉइंट को z पे ट्रांसफर करना है. तो मैंने x टू y का डीलैट निकाला, y टू z का डीलैट निकाला, दोनों को कंबाइन किया, मेरे पास एक डीलैट आ गया. अब मैं ये अप्लाई कहाँ करूं बेटा? डू आई हैव द लैटिट्यूड ऑफ x नोन?
ओके, अंडरस्टूड सर. हमारे पास x की वैल्यू नहीं है तो हमारे को dr पे ही लगाना पड़ेगा, तो इवेंचुअली वो सब एक्यूमुलेट होके हमें मिल जाएगा z का पोजीशन. गॉट इट सर.
एग्जैक्टली. कोई अगर चाहे तो पहले x का लैट लॉन्ग भी निकाल सकता है यूजिंग दिस इंटरसेप्ट लेग, बट दैट विल बी लिटिल लेंदी. अदरवाइज देयर इज नो प्रॉब्लम. आप पहले x का लैट लॉन्ग निकालो, फिर ये दो उसमें कोर्सेज और करंट लगा दो. Even then you will get the Z's position. That's also fine. Only thing is it will take little bit more time.
सर वन मोर डाउट. ये डायरेक्ट अगर सर मैं इसको ग्राफ पे प्लॉट करता हूं तो डायरेक्ट वी कैन फाइंड द पोजीशन ऑफ जेड.
उसमें एक ही दिक्कत आएगी बेटा, पोजीशन आप निकाल लोगे. दिक्कत ये आएगी दैट डिस्टेंस इन्वॉल्व्ड इज 81 माइल्स हियर, और डिस्टेंस अगर बड़ा होगा तो स्केल बड़ा लेना पड़ेगा, विच विल इंक्रीज द एरर्स. ये दिक्कत आएगी बेटा. अदरवाइज अगर हमारे पास चार्ट होता है,
अदरवाइज अगर तो सर डिस्टेंस अगर कम है तो वी कैन टेक द डायरेक्ट पोजीशन ऑफ द जेड.
दैट्स राइट बेटा. अगर ये डिस्टेंस 81 माइल की जगह पे 8 माइल्स होता तो मे बी आई कुड हैव टेकन इट.
ओके ओके. मतलब 81 माइल में भी सर एरर आएगा क्या सर?
आएगा बेटा, आएगा. 81 तो बहुत बड़ा हो गया. 10-15 माइल से ज्यादा आप लोगे ना, जब आपका स्केल जो है वो 1:5 से ज्यादा आने लगे तो फिर तो एरर बढ़ जाएगी बेटा.
ओके, मींस 10-15 माइल से ज्यादा होगा तो वी विल फॉलो दिस प्रोसेस.
दैट्स राइट बेटा. इट इज बेटर टू फॉलो द कैलकुलेशन देन.
Okay, okay. Thank you.
So one more thing, the second step it should be DLAT DR2 point Z, right?
Second step it will be from X to Y.
So the right hand side where it is written, that should be point Z, right?
DR2, that's right beta. You pointed it right. This should be DLAT from DR to point Z. That's right.
सर पीएल बनेगी वो जेड पे बनेगी ना सर?
एग्जैक्टली बेटा. जो ये जेड पोजीशन अब हमारे पास आई है, ट्रांसफर्ड पीएल यहीं पे बनेगी.
हाँ जी सर. अगर मैं डीआर टू आईटीपी जो फर्स्ट पॉइंट आपने लिया ना सर 081 और वो 12.2 माइल्स, अगर वो मैं नहीं लेता हूँ, ठीक है, डायरेक्ट अपना स्ट्रीमिंग आता हूँ, फिर जो भी मेरा जेड पॉइंट आएगा उस टाइम अगर 12.2 माइल्स उससे अवे करता हूँ तो भी बात सेम पड़ेगी ना सर?
राइट बेटा. आप ये बोल रहे हो कि अगर मैं डीआर पे अपना कोर्स और करंट लगाता हूं, जो पोजीशन मेरे पास आएगी उस पोजीशन पे फिर मुझे इंटरसेप्ट बाय प्लॉटिंग लगाना पड़ेगा, क्योंकि आपने उसे कैलकुलेशन में नहीं लिया तो आप उसे प्लॉटिंग में लगा सकते हो. ऐसा भी किया जा सकता है.
ओके सर.
बड़ा कॉम्प्लिकेट हो जाएगा सर।
हाँ, दिस इज द सिंपलेस्ट वन बेटा। कैलकुलेशन कर ही रहे हैं तो देन डू ऑल द लेग्स बाय कैलकुलेशन, दैट इज द इजीएस्ट।
हाँ सर, सीधा डीआर से ले लो और खत्म करो।
बोलो बेटा।
सर ये डीलैट के लिए सर जो सब्ट्रैक्ट किया गया ये ऐड होना चाहिए सर अपोजिट नेम में तो।
ओके बेटा, हमारा इनिशियल लैटिट्यूड जो था वो था 1741 साउथ और जो डीलैट है वो है 52.5 मिनट साउथ। हमने इन दोनों को ऐड किया तो ये बन गया 18 डिग्री 33.5 मिनट साउथ। राइट बेटा?
मैं इस कॉलम की बात कर रहा हूँ, मैं इस कॉलम की बात कर रहा हूँ सर जिसमें ये नॉर्थ और साउथ कॉलम नहीं करके
ओके,
जो रिजल्टेंट डीलैट और
किसको ऐड करना चाहिए था बेटा?
54 और 1.9
अपोजिट।
ओके बेटा, मैं समझाता हूँ तुम्हें। देखो, जो ये 1.9 मिनट का डीलैट है ये नॉर्थ डीलैट है, मतलब आप डीआर पोजीशन से पहले 1.9 मिनट नॉर्थ में गए। और जो 54.4 है ये साउथ डीलैट है, मतलब आप एक्स पॉइंट से जब जेड पे आए तो आप 54.4 मिनट साउथ में आ गए। तो ये तो दोनों सब्ट्रैक्ट होंगे ना बेटा, क्योंकि आप ऑपोजिट डायरेक्शन में जा रहे हो।
सर ये जो 1.9 मिनट है ये हम लोग बाय कंपास मेजर कर रहे हैं क्या सर?
नहीं बेटा, ये हमने फॉर्मूले से निकाला है। हमारा DR2 ITP कोर्स है 081 विच इज नॉर्थ 81 ईस्ट, डिस्टेंस है 12.2। आप कैलकुलेटर में डालिए डिस्टेंस कॉस कोर्स 12.2 इंटू कॉस ऑफ 81, सी इफ यू गेट दिस आंसर।
ओके सर, ओके, ठीक आ रहा है सर।
वेरी गुड बेटा। So if we are comfortable, shall we move ahead?
Yes sir, yes sir.
Great
Yes, sir.
beta, let's go. We have the Z position calculated now. अब हमें बेटा डायरेक्टली Z की पोजीशन को प्लॉट करना है और हमारी ये जो PL है ये ट्रांसफर हो जाएगी। So once this PL is transferred, the second PL can be also plotted and it becomes a simple simultaneous kind of question. So let us see the plotting now. Z position हम लोग use करेंगे. So let's see.
So I'm sure this concept of day's work, which we're all conversant with, use of parallel and plain sailing concept, we are all conversant with. Looking at the rough diagram, if the rough diagram was not made, it would sometimes be confusing. Why? Because actually the vessel was somewhere on the PL, so vessel's movement has been from the PL only. But we had to include this so that we could get the coordinates of point Z. So now having got point Z through which to transfer the PL, it's lat long. We also know the direction of the transferred PL, it shall be perpendicular to the azimuth in the morning. That shall be 171 degrees to 351 degrees true. We know that the second observation has been latitude by meridian altitude, so observed lat is 18 degrees 40 minutes south. Direction of the second PL is east-west. D lat from Z to observed lat is 6.5 minutes south. So you can see it's 6.5 minutes south. Now having got this, now it's a case of simultaneous observations. Only thing is one is a transferred PL, other is an observed PL. So we get going with the plot. We have on the screen latitude of Z coming up here. We have the longitude of Z coming up here. So obviously point Z is here at the intersection of the two. So that is point Z. It's through point Z that the transferred PL has to be drawn. We are all conversant with this part. So there comes the transferred PL with two arrows at each end. Now we choose on a suitable scale. 1 centimeter is equal to 1 mile. Why? Because the D lat is only 6.5 minutes south. So we can just mark that off and mark the observed lat. So here comes the observed lat. That is the lat at the time of second observation. The second PL shall coincide with the observed lat being east-west. So here comes the second PL. PL at the time of Marpas. So now this transferred PL and the second PL are for the same time. So this is the position of the vessel at the time of second observation. And now we know that the latitude is directly visible on the screen. We can read off the departure on the screen from the graph, which is 1 minute east from longitude of Z. Departure is converted into D long. You can see all this working coming on the screen. And then that D long is applied to the longitude of Z, and that gives us the fixed long. And eventually we get the coordinates of this fix as 18 degrees 40 minutes south, 178 degrees 53.9 minutes west. Please see here this longitude of 1.8 minutes east applied to longitude of Z gives us this longitude of fix, and therefore through deployment of our knowledge of simultaneous observations we can get this plot done and get our answer.
Okay, beta. So this is the plot in front of us now. Have a look at this. Let me know your doubts, beta.
एक बार वो डी लॉन्ग का समझा दो सर, वो वही कंफ्यूजन करता है बार बार मेरे को, बाकी तो सही है.
Means how did we get the D long from this departure?
नहीं सर, डी लॉन्ग से लॉन्गिट्यूड जो आता है ना सर, मैंने शुरू में पूछा था.
Okay, okay बेटा, ठीक है. You mean to say 180 meridian pass करेंगे, west से east जाएंगे, which direction we are moving, all these, then we will move further, so that I'll tell you later, don't bother. So अब मैं बेटा white board open कर रहा हूँ. Let us see D long की concept जो है, we can understand if there is a issue. So
क्लियर हो जाएगा.
Okay बेटा, can you tell me the positions बेटा, दोनों positions बता दोगे?
हाँ yes सर. पोजीशन है सर, फर्स्ट पोजीशन 77 डिग्रीज 08 साउथ, 166 डिग्री 30 मिनट्स ईस्ट. And second,
I'm just taking the degrees so that it is simple. What is the longitude?
166 30 east.
Okay, 166 30 east. Let's take 166 east. This is the first position, and we are going to
second position है 37 49 north.
Okay. Longitude beta?
And longitude 122 25 west.
122 25 west. So let's write 122 west. So these are the positions. This is A, and we are moving on to B. ओके अब मुझे इसकी अगर डायग्राम बनानी होगी तो मैं कैसे बनाऊंगा? सबसे पहले तो मुझे समझ में आ गया दैट आई एम मूविंग इन द नॉर्थ डायरेक्शन. 77 साउथ से मैं 37 नॉर्थ में जा रहा हूं. दैट मींस आई एम मूविंग नॉर्थवर्ड्स. अब मुझे पता करना है कि मैं ईस्ट जा रहा हूं या वेस्ट. सो कैसे पता करूंगा? मेरे पास ये दो लॉन्जिट्यूड्स हैं, दोनों डिफरेंट हेमिस्फीयर्स में हैं. सो व्हेनेवर द लॉन्जिट्यूड्स आर इन डिफरेंट हेमिस्फीयर्स we add the values to get the D long. So मैंने ये values add की 166 plus 122. This gives me a value of 288 degrees. And direction क्या आती है? We are going from east to west, so the direction of the D long will be westerly. ये हमारा पहला step है बेटा. Up to here clear?
Yes sir, clear.
अब ये जो value है ये 180 से बड़ी आ गई, तो मैं इसे 360 में से सब्ट्रैक्ट करूंगा. 360 माइनस दिस, राइट? सो व्हेन आई डू दैट आई गेट ए वैल्यू ऑफ 72 degrees. And when I subtract it from 360, I have to change the name. So this west changes to east. So this is my D long. ये D long निकालने की टेक्निक है. ये D long आ गया बेटा 72 degrees east.
Clear sir.
Are you okay up to here?
Yes sir, clear.
Very good. So we are moving in the northeasterly direction. I hope you will be able to make the diagram now.
Yes sir, yes, correct.
Great beta. Any more doubts?
हाँ सर, ये तो
सर
मुझे
एक बार
क्लियर था सर,
डायग्राम इसका बता दीजिए।
मैंने
ये
बताया
लो
था
बेटा।
सर, ये मुझे क्लियर है। मुझे क्लियर क्या नहीं है सर, जब P की वैल्यू आ जाती है,
हाँ
P की वैल्यू आ जाती है और एक लॉन्गिट्यूड हमारे पास रहता है, हमें दूसरा लॉन्गिट्यूड निकालना रहता
इफ यू हैव ए एग्जांपल जस्ट गिव इट टू मी, मैं वो भी एक यहाँ करके देखते हैं।
है। इसी में है सर, इसी क्वेश्चन में है।
ठीक है, अभी कर लेते हैं बेटा। somebody was
प्लीज
saying इसकी
ड्रॉ द
डायग्राम।
डायग्राम फॉर दिस।
अभी लो बेटा, अभी ड्रॉ कर रहा हूँ। हायर लैटिट्यूड जो है साउथ में है, तो मैं साउथ पोल पिकअप करूंगा। ये मैंने यहाँ साउथ पोल पिकअप किया और मैंने इसको नाम दे दिया P. I am moving in northeasterly direction. So northeasterly direction means something like this. This is how I'm moving. So let me make the great circle track. So ये मैंने great circle track बना दिया। मेरी पहली पोजीशन जो है वो यहाँ आ जाएगी। This is A. I am moving like this in the northeasterly direction. ये मेरी दूसरी पोजीशन आ जाएगी। This is position B. अगर आप चाहो तो इसमें इक्वेटर भी बना सकते हो, because we are moving from south to north hemisphere. Equator will be somewhere here. This will be the equator. And this will be our PAP triangle. ये रहा बेटा डायग्राम on your screen.
यस सर, ठीक है सर। एक चीज सर, आपके पास सॉल्यूशन है ना सर इसका?
हाँ, that's right बेटा।
हाँ सर, वो खोल लीजिए सर, उसमें ज्यादा क्लियरली सर डिस्कस कर सकते हैं कि प्रॉब्लम कहाँ है, क्योंकि अभी आगे
हम जैसे हमने अभी बनाई, so we have the diagram here.
ठीक है सर।
इसके बाद हम आ जाते हैं यहाँ पे।
जी सर, अभी इसमें सर जब वर्टेक्स के कोऑर्डिनेट निकालेंगे ना सर, तो इसमें देखिए P एंगल निकाला हुआ है सर, ये लिखा है P is equal to 9900.7।
वेरी गुड, ये रहा बेटा 99.0.7, दैट्स राइट।
ये इसके बाद सर ये लॉन्गिट्यूड ऑफ वर्टेक्स कैसे आया है और ये डी लॉन्ग कैसे अप्लाई होता है,
अभी बता रहा हूँ बेटा। सबसे पहले तो आप ये देखो कि हमने पापा ब्रेवो विक्टर ट्रायंगल को यूज किया है, करेक्ट?
करेक्ट सर, करेक्ट।
सो पापा ब्रेवो विक्टर ट्रायंगल में जो ये 99 का डी लॉन्ग आया है, दैट शुड बी दिस पर्टिकुलर एंगल।
यस सर, करेक्ट।
Very good. So now tell me one thing. When you are moving from Bravo to vertex, are you moving in the easterly direction or westerly direction?
Sir, westerly direction.
Very good. So Bravo to Victor जब हम जाएंगे हमें westerly direction में जाना पड़ेगा. So basically the direction of this D long is westerly. With respect to B, Bravo, we have to go westerly 99 degrees 0.7 minute and we'll reach up to the vertex, right?
Yes, yeah, correct.
अब बेटा B का longitude क्या है?
B का longitude है सर, okay. 120 west.
Very good. So you can see that longitude here.
Yes,
ये रहा बेटा that longitude 120 to 25 west. So हमारा longitude भी west है, हमारा D long भी west है. तो जो हमारा फाइनल लॉन्ग आएगा दोनों ऐड हो जाएंगे बिकॉज दे आर ऑफ द सेम नेम्स।
ओके सर, ठीक है।
मैंने इन दोनों को ऐड किया, सो जस्ट डू दैट इन द कैलकुलेटर। 122.25 वेस्ट प्लस 9900.7
00.07 minutes 221 degree 25.6।
वेरी गुड, 221 डिग्रीज 25.6 हमारा आंसर आ गया।
जी सर।
और ये वेस्ट ही होगा क्योंकि वेस्ट से शुरू किया था और ज्यादा वेस्ट में गए हैं तो इसका नाम वेस्ट होना चाहिए।
जी जी, करेक्ट।
अब ये वैल्यू आ गई 180 से बड़ी, तो मुझे क्या करना है, 360 में से मुझे इसे माइनस करना है और नाम चेंज कर देना है। सो जस्ट सब्ट्रैक्ट इट फ्रॉम 360 एंड राइट द नेम एज ईस्ट।
जी सर, ओके।
व्हाट आर यू गेटिंग?
जी जी, 138 डिग्री 34.3 minutes।
वेरी गुड बेटा। सो दैट्स हाउ दिस इज डन। आई होप क्लियर नाउ।
Sir, I had some same doubts.
हाँ बोलो बेटा.
Sir, I have same doubts. Sir. For example, the P that it's 99 degree east, and we are going west, more west. So what will be this longitude of vertex, sir?
बेटा मैं समझा नहीं, तुम एक बार मुझे फिर बताओ कि क्या चेंज कर रहे हो इस क्वेश्चन में. व्हाट डू यू वांट टू चेंज?
If I change the direction, instead of going westerly, I'm going easterly.
ठीक है बेटा, मैं अभी डायग्राम बनाता हूँ. आप बोल रहे हो कि हमें वर्टेक्स को ब्रेवो के ईस्टर्ली बनाना है, करेक्ट?
यस सर, यस सर.
वेरी गुड. मैं अभी डायग्राम बना रहा हूँ बेटा. ये मैंने इरेज कर दिया. सो आई एम मेकिंग अ डायग्राम नाउ. सो विक्टर को, वर्टेक्स को हमने ब्रेवो के ईस्ट में बनाना है. सो ये रहा बेटा, ये मैंने. अब अगर आप इसको ईस्ट में बनाओगे तो एनीवे पोल साउथ में रखना है.
Yes sir, same question sir. I just want to know the direction of V, then longitude of V. How to find?
तो फिर ये ऐसा बनेगा बेटा. एक मिनट, लेट मी रीलोड इट. सो ब्रेवो वुड बी हियर. हम अब जाएंगे ईस्टर्ली डायरेक्शन में, एंड दिस इज वेयर द वर्टेक्स इज. लेट अस से दिस इज वेयर द वर्टेक्स इज, एंड ये जो एंगल आया है इसको सेम रखना है बेटा, 99.
यस सर, सेम
99 रखना है. अब हम ईस्टर्ली डायरेक्शन में जा रहे हैं. बी का जो लॉन्जिट्यूड है वो है 122 डिग्रीज वेस्ट.
Yes,
so now you want to find out the longitude of the vertex, right बेटा?
Yes. Yes sir.
Very good बेटा. अब ध्यान से देखना बेटा, हमारा इनिशियल लॉन्जिट्यूड है 122 वेस्ट. वी आर मूविंग 99 डिग्रीज इन द ईस्टर्ली डायरेक्शन. सी द राइट साइड इज ऑलवेज ईस्ट. सो जब आप ईस्टर्ली डायरेक्शन में जाओगे, 122 वेस्ट आपका इनिशियल लॉन्जिट्यूड है. जब आप ईस्टर्ली डायरेक्शन में जाओगे तो वेस्टर्ली लॉन्जिट्यूड तो डिक्रीज होगा ना बेटा? Right,
sir, yeah, sir. Is it possible, sir, if 122 and we are moving more to west? In this case, no.
You are moving where, beta?
For example, can I assume by this arrow that from B to V I am moving more to west? No, is it not possible? Is that possible, or right direction always east?
Right direction always east, beta. ये तो 100% correct है. Remember this, north, south, east, west. This never goes out. ये तो ऐसे ही रहेगा बेटा. नॉर्थ, साउथ, ईस्ट और वेस्ट तो इसी डायरेक्शन में ही रहेंगे. दे विल नेवर चेंज. ये तो टच स्टोन है बेटा. दिस विल नॉट चेंज.
Irrespective of poles, it will be remain same, right? So right is east.
Anywhere बेटा, anywhere on earth, कहीं पे भी हो आप, कोई भी क्वेश्चन है, नॉर्थ हेमिस्फीयर, साउथ हेमिस्फीयर, दिस इज नॉट गोइंग टू चेंज.
So 23 degrees.
Okay.
East is always right.
Yes, sir.
Okay.
So is the doubt cleared now, or still is there? It is there.
122 minus 99 ईस्ट को, तो 23 आया सर. उसकी डायरेक्शन 23 क्या सर, वेस्ट रहेगी ना?
ये लो बेटा, 122 वेस्ट से हमने 99 ईस्ट सब्ट्रैक्ट कर दिया. So we have 023 now, correct?
Yes sir.
And 122 वेस्ट था, 99 ईस्ट में गए, so 023 भी वेस्ट ही होगा बेटा.
ठीक है सर. ओके, गॉट इट सर, क्लियर.
अगर ये डी लॉन्ग 122 से ज्यादा होता, लेट अस से इट वाज 130 डिग्रीज, तो फिर ये ईस्टर्न हेमिस्फीयर में चला जाता.
एक सेकेंड सर, अगर मान लीजिए 130 होता, आप कह रहे हो 99 की जगह,
राइट? सो 122 वेस्ट में थे आप, एंड आप 130 डिग्री ईस्ट में चले गए उसके. 130 डिग्री ईस्ट में चले गए. सो आपने 122 वेस्टर्न हेमिस्फीयर तो कवर किया ही किया, उसके ऊपर से 8 डिग्रीज और ईस्ट में चले गए आप. सो द आंसर वुड बी 008 डिग्रीज ईस्ट लॉन्जिट्यूड. You were at 122 west. You moved 130 degree eastwards. So 130 में से पहले 122 में तो आपने वेस्टर्न हेमिस्फीयर पूरा क्रॉस कर लिया, और बाकी के जो 8 डिग्रीज बचे, you have gone 8 degrees eastwards. So the answer would be 008 east. That will be your final long.
Okay, sir, got it. Okay, sir, got it.
Okay, beta. All right. So clear, beta. Shall I close it?
Sorry, sir. I am sorry, sir, to say that to you. I am still confusing, sir. Confusing that in that 99 east, how it becomes 23 west. The long.
Okay. पहले तो इसको erase कर देते हैं. Let us erase this. Confusion आ रहा है कि ये 023 west कैसे आया?
Yes, sir.
Okay. You were at 122 west longitude. You went 99 degrees east. Now tell me, when you are in westerly longitude and you move eastwards, is your longitude going to increase or decrease?
Longitude is decrease.
It will decrease. That's why you see a negative sign here, because the longitude is decreasing. अगर आप 122 वेस्ट में हो और वेस्ट में जाओगे तो लॉन्जिट्यूड बढ़ेगा, बट अगर आप ईस्ट में जाओगे तो लॉन्जिट्यूड कम होगा. दैट्स व्हाई वी सबट्रैक्टेड इट एंड वी गॉट द आंसर 023.
Okay, sir. In that, okay. Yeah.
Okay, beta.
Yes, sir. If that is 99 west, then I will add, right, sir?
That's right. अगर ये 99 वेस्ट होता, अब एक्सेलेंट बेटा, यू कैन डू इट ऑन प्लेन शीट, नो इश्यूज. आपके आंसर्स कभी भी एग्जैक्टली मैच नहीं होंगे, जैसा चार्ट वर्क में भी होता है, बिकॉज प्लॉटिंग टूल्स की अपनी एरर होगी. देयर विल बी सम माइनर डिफरेंस. डोंट वरी अबाउट दैट. यूज ए प्लेन शीट. ग्राफ पेपर है, उसे भी यूज कर सकते हो, एंड यू कैन डू एनीवेयर.
सर ग्राफ पेपर हम अपना ले जा सकते हैं सर?
Sliding ruler, yeah. Yes, that would be great. Sliding ruler would be great to draw parallel lines. Some people are comfortable with set squares, so both are fine.
सर
बोलो बेटा.
सर ग्राफ पेपर हम अपना ले जा सकते हैं एग्जाम में?
बेटा आप लेके जा सकते हो, बट इट इज अप टू द सर्वेयर टू अलाउ इट और नॉट. बट आई वुड नॉट रिकमेंड दैट. उसका रीजन मैं बताता हूँ आपको. मान लो सिर्फ आप ही लेके गए ग्राफ पेपर और किसी के पास नहीं था, आप अपना वाला ले गए, आपने बोला जी मैं यूज करता हूँ, आपने यूज भी कर लिया, उसने अलाउ भी कर दिया, आपने लगा दिया. जब ये सारे पेपर चेकर के पास जाएंगे, वो देखेगा बाकी सब बच्चों ने प्लेन शीट में किया है, आपने ग्राफ पेपर लगा के किया है. ओके, सो दिस थॉट में कम इन हिज माइंड दैट हाउ डिड यू गेट ए ग्राफ पेपर, और किसी के पास तो था नहीं, एमएमडी में तो होता नहीं है ग्राफ पेपर. सो ऑल दीज थिंग्स विल स्टार्ट प्लेइंग इन हिज माइंड. सो इट इज ऑलवेज बेटर टू गो विद द फ्लो, right? Otherwise no issues.
Thank you, sir.
Okay, so great beta. So I hope things are clear now. Dhruv is there or Dhruv is gone? Dhruv is gone. So good. Dhruv had some anticipation ना बेटा, शुरू में ध्रुव बोल रहा था ना कि प्लॉटिंग समझ में नहीं आ रहा है. So good, he's understood it and gone. That's great.
कोई बीएससी वाला था सर, अब नाम नहीं पता.
हाँ, I think it was Dhruv only. So वो चला गया है. That's a proof that he's understood everything. So great, good. So okay, beta, up to here, okay?
Yes, sir. Thank you.
Okay, sir. Thank you.
Thank you.
Okay, beta. Great.
Thanks.
See you.
Great, sir.
See you in the next class. Jai Hind.
Jai Hind, sir.
Thank you, sir. Great, sir. Thank you, sir.